I'd like to say a few words on the selection of the regressors. I would recommend starting with a rather comprehensive set of explanatory variables, of variables that make sense from the point of view of experts in the field, of those who have experience, and from those people and those well-informed people, you would do a prior selection of promising and plausible regressors. Then you would run the regression, and you would at least take a look at two aspects as a preliminary and important filter. One would look, for instance, whether the coefficients have the expected and right sign. What do I mean by that? For instance, in this one of the previous regressions that we did, although this was only a regression with a rather small number of observations, so from that point alone it was not meaningful. But we had a coefficient here which said that if the living area goes up, the price would, holding everything else constant, so for comparable houses, the price would go down. The price would go down on average if the size of the living area increases, and that's not a plausible result. So in this particular case, that is most likely due to the fact that this data set is too small. But in general, a wrong and unexpected and strange sign would be an indicator that something's wrong with the regression, something's wrong with the indicator that you took into account. So I would eliminate those regressors. Other than that, I would also take a look at the precision of the estimated coefficients, and if these are too low, if the precision is too low, for instance indicated by the fact that this t-statistic is too low, and as a rule of thumb one could use a t-statistic of 2 or 1.5. If you find coefficients that are below that number, you might want to eliminate those regressors. And finally, what you could do is you could look at the information in this part of the table. It does not make sense to look at the R-square, and I already criticized R-square because it's framed in terms of the variance of the errors, and that's hard to relate to because it has these strange units of measure. It relates to strange units of measurement. The other main drawback of R-square is it always increases if you add additional regressors. So even if the regressors you put in are not significant, or if they are just meaningless, it turns out that R-square goes up. And that's why people came up with an adjusted R-square. And this adjustment takes into account the number of regressors. So we have 4 here, we have 9 here, and we have 6 here. So in order to compare those regressions with a differing number of regressors, the minimum you would need to do is to look at this adjusted R-square and then look at and pick the regression with the maximum adjusted R-square after accounting for the number of regressors. And what I really recommend as a final criterion would be to take the standard deviation of the errors from the regression, the standard error in short, so the standard error from the regression. And in previous videos, I have also already used that number, and you've seen, and we had this discrepancy, this slight discrepancy, that when you calculate the regular standard deviation from residuals, you get a number which slightly deviates from that standard error that you find in that table. And the reason is this standard error here also adjusts and accounts for the number of regressors. So it does, in a way, a similar adjustment as this adjusted R-square. The standard deviation of the errors calculated in the usual way would also always go down if you add additional regressors, but the standard error that is put in this table is already adjusting for the number of regressors, and it might also go up. It gets worse if you add regressors, but only if you add regressors that are like meaningless or not very informative, let's put it this way. So picking a model that has the minimum standard error would be a good way to guide you. It would account for the number of regressors, and what is also important, at the same time it gives you information about the magnitude of the errors, of the residuals, basically of the magnitude of those things that drive the difference between observed prices and expected prices. So they give you a guideline of how much risk is left to be taken when you want to use this regression for prediction or valuation. And it is measured in the units of the dependent variable, so it's measured in the same units of the variable that you are primarily interested in. And in this particular case, you could pick, for instance, the model number, the second one here, which has the minimum standard error